Okay, example number 1. Determine whether the given function is proper or improper. If improper, convert into proper function. The first question, fx equal to 3x over by x squared plus 2. So, just focus on the highest degree of numerator and highest degree of denominator. So, this one, n, which is numerator power, is less than denominator power. So this one considered as proper function. Okay, so this is proper function. Second question, x squared plus 3x. So this is the highest degree of numerator over by x power of 4 plus 5x squared. So this one also numerator is less than the denominator. So you will have also proper function. The third one, x squared plus 3x minus 4. This is the highest degree for numerator. Over by x squared minus 2. So you have the same power for numerator and denominator. So this one considered as what? Improper function. Okay, make sure improper, you know the power of numerator is equal or more than your denominator. So if improper, you have to use the long division to convert from improper to proper. So just use the long division, x squared plus 3x minus 4 divide by x squared minus 2. So you have what numbers? If you multiply with x squared, you get x squared. So you have 1 times x squared is x squared. 1 times negative 2 is negative 2 minus. This is 0. 3x minus 0 is 3x. Negative 4 minus negative 2 is negative 2. So the function become fx is equal to, how to write the answer? 1 quotient plus remainder 3x minus 2 over divisor x squared minus 2. So this one, your function right now, check whether this is proper or improper. The highest degree of numerator is 1, the highest degree of denominator is 2. So this one considered as proper function. Okay, so make sure first step you have to recognize whether your function is proper or improper. If improper, convert to proper using the long division method. Okay, then example number 2 is for you to applying the rule just now. Remember the rule, the first and the second rule is for the linear. The rule C and D is for the irreducible quadratic. Okay. So just write the partial fraction decomposition of the function. We just want to decompose only this given function. Okay. Just focus on your denominator. Okay. First check whether the function is proper or improper. So this one, you have 5 only for numerator, but denominator you have 2x times x is quadratic, 2x squared. So this is proper function. Okay, proper function. So what is the rule? You have linear factor for 2x plus 1, another linear factor which is x minus 3. So you will decompose into 2 small fraction, which is the first one over by 2x plus 1. The second one over by x minus 3. And then what is your numerator? You just write the unknown. Let's say we write as a and b. Okay. So this one you are applying rule A, which is linear factor. Look at part B. 2 plus x is linear over by x cubed minus x squared. So the highest degree of numerator is 1. Denominator is 3. So this is also proper function. Okay. So you want to decompose into how many small fraction? You have to factor first denominator parts. So what is the factored form? You have 2 plus x over by, you can factor out x squared, and then inside will be x minus 1 only. Okay. So right now, if you look at your denominator, you have x linear. This one repeated 2 times. X squared. This is linear repeated 2 times. Not fall under the irreducible quadratic. Irreducible quadratic is function that you cannot factor further. But this is solid x. This is repeated. So for this one, repeated linear. But this is the linear function only. So you will apply rule A and B actually. Rule A and B. Okay. So how many fraction that you want to decompose? 3. The first one is over by x. The second one is over by x squared. The third one is over by x minus 1. Okay. Then what is your numerator? All unknown A, B and C. Okay. So this one is applying rule A and also rule B. Okay, look at part C. 3y plus 5 over by x squared plus 1 square. Okay. Y squared plus 1 square. So this one, y is power of 1. Denominator y is power of 4. So this is also proper function. So if proper, you can just proceed to the next step, which is factor denominator. The denominator has already been factored. You apply the rule. So which rule? Y squared plus 1. Can you factor further this one? No. If you find the rule. So how many fraction that you want to decompose? 2 according to the degree here. So you are having over by y squared plus 1 plus over by y squared plus 1 square. And then if your denominator is quadratic, your numerator will be linear. So you have ax plus b plus cx plus d. Okay. This one you are applying which rule just now? Rule D. This example is for you to decompose only. Just apply which rule. Okay, part D. 2y plus 1 over by y squared plus 4, y squared minus 4. Okay, y squared plus 4, y squared minus 4. So check whether this is proper or improper. Y is power of 1. Denominator y squared is y power of 4. So this is also proper function. Okay, if proper, proceed to the next step, which is factor denominator completely. If you look at this one, y squared plus 4, you cannot factor for complex roots. Okay, complex roots. But y squared minus 4, you can factor further this one. So you have 2y plus 1 over by y squared plus 4. Y squared minus 4 is y plus 2 and y minus 2. Okay. So this one is irreducible quadratic. This one is linear factor. So you are combining rule A, which is linear, and also rule C, which is irreducible quadratic. So you will have 3 fraction, which is y squared plus 4 plus over by y plus 2 plus over by y minus 2. So what is your numerator? This one quadratic, so your numerator will be linear, which is ax plus b. And then this one is linear, y plus 2, so your numerator will be constant only. So you have c, this is d. Okay, so this one combine rule A and also C. Okay, which is linear factor and also irreducible. Okay, part E. You have x minus 1 over by x minus 2 square, x square plus 1. This is also proper. X power of 1. Denominator is x power of 4. X squared. So this is also proper function. So you want to decompose into how many fraction? This one is linear but repeated 2 times. This is quadratic. So you will have 3 small fraction, which is x minus 2 plus over by x minus 2 square plus over by x square plus 1. Okay. And then the numerator will be a constant. X minus 2 also constant. X squared plus 1, you have the quadratic. So your numerator will be linear. See, x plus d. So this one you are combining rule B, which is repeated linear, and also C, which is irreducible. Okay, the last one. This is the example of improper. The first 5 example is proper. This one is the highest degree for numerator is 3, denominator is 2. So this is improper. If improper, convert to proper using the long division. So this is the long division method. What is the value? If you multiply with x squared, you get 2x cubed. So you have 2x. So put it here. 2x times x squared is 2x cubed. 2x times 0 is 0. 2x times negative 1 is negative 2x. Okay, minus this one. 0, 0. X minus negative 2x is 3x. Bring down this number. You have plus 1. Okay. So your function will be... This is the question just now. I made them just copy back the question. So this one is actually equal to... How to write your answer? Quotient 2x plus remainder 3x plus 1 over by x square minus 1. So this one is proper function. Make sure after you divide using long division, the function will be in the proper form. Okay. So just focus on this one. Follow the step. Okay. After proper, you have to factor the denominator completely. So just follow the first answer, 2x plus 3x plus 1. Factor further, x square minus 1 is x minus 1 and x plus 1. And then this one is linear. Linear factor only. So you have, this one just follow 2x. You have 2 small fraction, which is x minus 1. And the second one is x plus 1. And then the numerator will be constant only. So let's say this is A, this is B. Okay. So this one is you are applying rule A, which is linear factor. So after you convert into the proper function, after that, just focus on this one. This is the things that you want to decompose. The first term ni remain the same. Okay.